Hello everyone, welcome to another webinar series organized by the Lanka Consulting Group. Before moving on to today's session, let me give you a brief on Lanka Consulting Group. Lanka Consulting Group or LCG is an online platform developed to address the consultancy needs in different sectors of Sri Lankan economy. Users of LCG could be both organizations and individuals, and they can visit LCG website to find experts from different sectors to match their business needs. LCG works with intentions to address business challenges, particularly to small and medium enterprises. Some of the fields of expertise covered by LCG are business and finance, marketing and sales, HR, manufacturing and processing, technology, tax and startup mentoring. Now you could visit our LCG website on www.lankaconsultinggroup.com for more information. This webinar series will be simultaneously broadcast live on Facebook for the viewers who are unable to get in touch with us via Zoom link. With that, let's move on to today's session. Coenergi Private Limited. Coenergi is a specialized provider of sustainable and resource-efficient design in building engineering services, and they focus on new and sustainable solutions for clients through the consultative approach. A view of challenges coupled with an application of modeling and simulation techniques and access to the best minds in the engineering field will offer the clients of Coenergi a distinct advantage. The solutions provided at Coenergi are MEP Design Consultancy, Energy Audit, Solar Roof Design Consultancy, Green Building Certification, and Medium High Voltage Power System Design. The consultations for today represent the representatives of Coenergi, Mr. Divanta Ekanayaka and Ms. Reshadi Veerasurya. Mr. Divanta Ekanayaka is a sustainability lead executive, holds a BSc in architectural engineering from the University of Wyoming, USA. His specialized including green building modeling and simulation for energy efficiency and sustainability in built environment. Ms. Reshadi Veerasurya is a sustainability lead executive, holds a BSc in Green Technology, honors degree from the University of Ruhuna. She is expert in green building certification, sustainability and environment conversation. So ladies and gentlemen, let's warmly welcome Mr. Divanta Ekanayaka. Over to you, Mr. Divanta.
Okay, thank you. Can everyone see the slides?
Yes, Mr. Divanta.
Okay, so good morning, everyone. So before we begin the webinar, please do me a favor and mute all the microphones so we can proceed our webinar without any interruptions. So first of all, the length of our webinar would be around 50 minutes to 1 hour. So I will conduct the first part of the presentation and I'll hand over to my colleague Reshadi to do the last part of the presentation. So in the meantime, if you have any questions, feel free to drop your questions in the chat box. We'll try to answer all of your questions and get back to you via email. So let's begin the presentation. Okay, so the prime objective of today's webinar is to describe how green building approach when it comes to design or even retrofitting building can be used to reduce the operational cost during the operational phase of the building. So I'll begin the presentation by stating what are the major operational costs of the building, and then I'll move on to describing what should be our goal when it comes to operating a building and also to how to achieve it. And also we have to prioritize our investments. And then last but not least, I'll describe how integrative approach is actually quite necessary to design and optimize a building to actually to have a functional building that result in reduced operational cost. So first of all, as many of you know, commercial buildings, the operational cost of commercial building mainly comprises of two things. They are utility bills and repairs and adjustments. Utility bills mainly comprises of energy bills, but also water bills as well. And repairs and adjustments mainly include routine maintenance, malfunction, I mean the repairs caused by malfunctions, and also retrofitting done to increase the efficiency of the building, and also adjustment made to address occupant complaints. So when we so our goal when it's come to operating a building, our goal is to reduce cost without compromising occupant comfort. So that means basically we have to balance the both sides. So occupant comfort is mainly depends on the indoor environmental quality, and indoor environmental quality has basically three factors: thermal comfort, indoor air quality, and also daylight. So the best way to achieve our goal to balance cost and the quality, the indoor environmental quality, is design or retrofit the building itself to maximize the efficiency and also to optimize the indoor environmental quality. So you cannot actually compromise indoor environmental quality, because indoor environmental quality actually directly affect the occupant productivity as well. So that ultimately result in a poor, I mean that ultimately reduce operational cost as well if you improve the indoor environmental quality. In addition to that, you know, the most of the later adjustments done to systems in buildings during the operational phase happens due to occupant complaints. So if you design the building itself to have a proper indoor environmental quality, you can avoid those unnecessary repairs and maintenance. So basic rule of thumb is to invest in your building during the design stage. So you will gain the reduced operational cost during the operational phase. So that will be a good investment during the design phase. So most of you already know, I'm pretty sure the biggest operational cost of a building is our utility bills, and energy bills comprises the biggest portion. And air conditioning system and the ventilation system actually responsible consume most of the energy, and also then comes lighting. So in when it's come to reducing operating cost, our priority should be to increase the energy efficiency first. So in conventional practice, basically buildings are actually designed without paying much attention to the energy efficiency. And they usually, the architect or the client, then usually hire system engineers to design the system to address the resulting demand. That can actually result in a very poor, efficiently working building. And actually that can actually result in high operating cost as well. So the green building approach is always to design the building itself to optimize the energy efficiency. So, and then you can handle that reduced demand using energy efficient systems. And installing renewable energy installations always comes as an optional thing, because the installing solar panels or something like that can be always done in any stage in the building life cycle. So as an example, if you consider the cooling load, the first priority should be to reduce the heat gain through the building envelope through optimizing the building itself. Then you can design the systems efficiently to remove that gain using the systems. So that should be always be the order, and the installing renewable energy such as solar PV always comes as the last option. So when you design a building from the scratch, the first design consideration would be to orient the building properly to minimize the solar heat gain, and also to determine the best or basically roughly the shape of the building, also to determine other parameters such as shading and basic shape of the building to minimize the solar heat gain. So usually that can be done using energy simulation during the design early design stage of the building. So basically the schematic design phase. So once you have determined the orientation and basic shape, the next priority would be to determine the optimum glazing to wall ratio. So in tropical climate especially, most of the heat gain comes through building envelope through most of the actually the most through glazing. So actually it should be our first priority to actually optimize glazing, but minimize glazing also can result in other issues such as reduce daylight gain and also that can directly increase your lighting load. So that definitely will affect your operational cost as well. So the green building practice is actually to optimize the wall to glazing ratio using energy simulation. So it is widely known that the wall to glazing ratio should be around like 40%. But as you know, that can actually completely depends on the orientation of the facade and also the space use and many other factors. So always the best approach should be to determine the glass to wall ratio during the schematic phase of the design using energy simulations. So once you have determined the orientation, glazing to wall ratio, and the basic shape of the building to minimize the heating load, the next priority should be to optimize the thermal properties of the envelope. So when it comes to roof, R value and SR value are the determining factors. So R value, probably as you already know, is the thermal resistance of the total roof assembly. That includes the roof structure and the roof materials and also insulation and everything. And SRI value stand for solar reflective index, and that means how much your roof surface can reflect solar heat, total solar radiation back into the atmosphere. So the higher the solar radiation, the higher the R value, the higher your thermal performance. And when it comes to walls, the same rule actually applies, but solar reflective index to a lesser extent because the direct solar exposure to wall is comparatively less compared to a roof. But when it comes to glazing, there are many determining factors. So one example would be solar heat gain coefficient, excuse me, and also visual transmittance value. So solar heat gain coefficient values actually determine how much solar heat is transmitted through your glazing. So actually the whole the heat gain, solar heat gain coefficient factor is actually few times higher than the thermal resistance value in a glass. There are many products in the market that are designed to optimize the thermal performance of glass. So they includes like multiplane glazing, reflective glazing, and low coating glazing. For example, in this case, you can see the double plane glazing with double plane and air barrier and a thermal barrier. So they are basically designed to increase the R value of the glazing. But the R value of the glazing is relatively low, less determining factor when it comes to heat gain through a glazing. So the solar heat gain coefficient is the one we should focus. So the low coating glazing, on the other hand, are designed to reduce solar heat gain coefficient. So reduce solar heat gain coefficient means reduce thermal heat gain, and also to it doesn't minimize visual transmittance as much compared to other glazing. So that means you will, through low coating glazing, you will reduce solar heat gain coefficient without compromising much of the visual transmitters, which means the daylight. So once you have optimized your building itself to minimize the heat gain of the building and also the lighting load, the next step would be to design your system efficiently. So as we already discussed, like most determining systems when it comes to energy efficiency would be air conditioning systems, ventilation systems, and also lighting systems, especially in commercial buildings, in office buildings and everything. So when it comes to designing air conditioning systems, the widely practiced rule is to use rule of thumb values. For example, tons per square footage values. And so as you already know, the thermal heat gain into a building, into a space can depends on many factors other than climate, including climate, orientation, glazing ratio, and thermal properties of the envelope. So the cooling load per square foot is or square meter is not always same, is not a general thing. So if you use the rule of thumb value to determine your cooling load, you will most likely end up with the incorrect value, and it will most likely result in oversizing or undersizing your um, air conditioning system. So that can ultimately result in operational issues as well as thermal comfort issues as well. So this will always negatively affect to increase your operational cost. So the best practice, and also in green building practice, this is the must. You have to always use energy simulations to determine the building cooling load. So you can actually emulate real conditions of the building and determine your actual cooling load. So, so when it comes to lighting, most people are familiar with that. There are a lot of energy efficiency lighting fixtures available, such as LED systems, but daylighting control can also be helpful to reduce the lighting load. So when it comes to water efficiency, the determining factors would be efficient fixtures and non-potable sources. So efficient fixtures include taps and water closets and urinals and everything designed to optimize the flow rate. So if you consider a single faucet or something, you wouldn't think there would be much of a things to consider there because the savings would be much smaller. But if you consider the cumulative effect, if you consider a single faucet that's been used like 20 or more times per day, and if you consider a year or longer time period, the cumulative saving would be much higher. So that is something you should consider when you choosing fixtures. Fixtures designed to optimize flow rates. And so now that we have discussed basic design strategies, let me explain how integrating approach can be useful to actually it's a must. Integrated approach is a must when you design a building to be energy efficient and reduce operational cost. So the green building approach is actually is to see the building as single functional entity. That means all the building professionals should work together to optimize their system. None of those systems work separately. They work with each other. So example, the architect's building design is obviously going to affect the cooling load of the HVAC design. And also the structural engineers, like the structural layout is going to affect the installation. So the best practice is to actually have design charrettes during the initial design stage of the building. From the very beginning, the schematic design to the final design, so all building professionals should actually have meetings to discuss like how each other's decision affect each other's systems, and to figure out interrelationships and to how to optimize the building as a single entity. And also there are other benefits when it comes to integrative approach. Those are includes like it can reduce conflict between parties during construction and also installation. And it also reduce alteration after construction that can actually drastically reduce unnecessary expenses. So this is it for the first part of the presentation, and I'll hand over to my colleague Reshari, and she will begin her part of the presentation by explaining practice scenarios in green building approach. So over to Reshari.
Yeah, thank you, Devanta. Can you all see the screen?
Yes.
Yeah. Now that Devanta has explained you on how to reduce the operational cost of the building using green building approach, now we are going to look into the global or the real world scenario of how green buildings have helped. First of all, let's see what is a green building. So, there are many perspectives in about green buildings, many definitions. Some people think that green buildings are buildings with a cultivated roof on that building. So, for a building to consider as a green building, they have to fulfill three main aspects. The first one is resource efficiency. That means the building has to be efficient in energy, water, materials mainly. So the next part is environmental performance. So if you have a building, there is a environmental impact that comes from the construction phase to the operational stage. So a green building will have strategies or measures taken to reduce these environmental impacts. Then the third part is occupant well-being. No matter how much efficient your building is or how much you have reduced your environmental impacts, it won't be called as a green building if your occupant is not comfortable. Have to consider about the occupant health and safety as well as the comfortability. So this is an example of green building with including the features that were discussed in the previous session. So you can see there is energy efficiency measures like renewable energy usage, some light colored roofing that has a higher flush and dual flush toilets, some rainwater harvesting practices. And regarding the environmental impact reduction, there is native plantings to help the habitat restoration, and some for occupant health and comfort level, there is carbon monoxide alarms, centralized dehumidification systems, and low emitting materials used like flooring and paints. You have to understand that no matter how many measures we use, we have to use them and plan them strategically to interact with each step, so that building have to perform as a green and a very efficient structure. So if we look at the current trend in the green building construction in this global scenario, there is a positive and improving trend for green constructions right now. So earlier in the beginning, it was only confined to more developed countries like UK, America, like that. But in the past few years, there is an improving trend in the developing countries, like Asian countries, African countries. They are going forward with these green building constructions. So this has been researched, and there have been many data collections regarding what actually drive towards this. So the basic and the most concerning factor they have identified is that client demands. So why actually the clients have put much interest, more interested about this green market? What we can see is that through awareness regarding green building practices, how their operation efficiencies and environmental impact reduction has caused more cost saving, has become a target to drive this green building construction industry. So if we see that the main part, the energy and water cost reduction, this is the most highlighted area in a green building. You know, US Green Building Council is a well-reputed institution that performs much larger research and data collections regarding green buildings. So they have identified that buildings are the largest consumer of energy sector. So as you know, any building, water and energy consumption is very high in this operational period. So the US Green Building Council has identified that using their data gathered, that energy use can be reduced from 25% or to 50% from using a green building practice. And for water use, it has identified as about 40% reduction can be expected from green buildings. So previously in the previous session, you identified that water efficiency and energy efficiency practices. And I'm not going to repeat that. So what I want to focus here is the water efficiency. We identified that water efficiency has two aspects, like efficient water fixtures and non-potable water use. But here, non-potable water use, we have to be very careful when we are selecting this option. So there are many potable water. So popular in Sri Lanka, wastewater treatment and rainwater harvesting. So we have to know that this wastewater treatment and rainwater harvesting has initial cost as well as an operational cost. Here, wastewater treatment includes a higher operational cost if it comparatively to rainwater harvesting. So as a client or someone managing your facility or building, you have to select which option you should be taking towards to reduce operational cost. In case, here we have to consider what exactly is the reason. What will be the ultimate purpose of your treated wastewater? You have to question yourselves. Should I use a very sophisticated or a process that has a higher operational cost like nanofiltration or activated carbon to just so you can eventually use that treated water for toilet flushing? So that question you have to focus, and you have to manage your wastewater treatment plant according to the use you're going to make in the building. Just like that, rainwater harvesting has also an associated cost. But relative to wastewater treatment, rainwater harvesting has a very minimum operational cost. This deals with problems like is there enough rainfall over the year? But regarding the operational cost, this has a very lower cost, because unless you are going to use that water for drinking purposes, you don't need to have much of the purification process. So even for drinking purpose, you can use only a primary treatment process. So this very lower cost other than wastewater treatment. So when you are managing your facility, when you are selecting a non-potable water use, you have to consider the estimations to select which would give you the highest benefit and which would have a lower operational cost. So the next part we will consider about the materials, because after energy and water, materials are the most important part in a building. From the construction phase to the operational stage, there are various materials used in this building. So related to the material, there comes a part waste. So if we say that you have used 300 kilograms of cardboard for your purposes, and now it is going to waste. Now you have to understand that 300 kilograms of cardboard was had an associated cost, and when it is wasted, you're going to be wasting a rather close amount, because you have already used, but it's only one time or two times. In a green building practice, it considers about diverting your waste from landfilling. There are measures you can take. There are many recyclers and reusing facilities in Sri Lanka. There are some examples here. You can sell your waste materials. So it won't make your total expense for that material is covered, but at least a part of your material cost is covered through that recycling or selling purpose. And another thing is your biodegradable waste. You can, in a facility, if there are many employees, you can have a higher food waste component. So, but to manage this food waste, normally it's used as a divert into piggeries or like that. So there are many options that can make your operational cost reduced by managing this waste. One is biogas production. So food waste is a very good method to divert as a biogas production. Biogas can be used for cooking purposes as well as for steam generation fuel. And another thing is your biodegradable waste can be used for composting. So thereby you can reduce your operational cost related to the landscaping practices. So there are many impacts we create because of our actions. So an externality is an adverse or an unintended impact caused by our actions. So there are many institutions in Sri Lanka regarding the environmental impacts. To reduce these impacts, they have created policies, procedures, regulations, all that. Building owners and building maintenance, you have to adhere to these policies and regulations. Here with the green building practices, you can manage these impacts, because green building practices are aligned with this environmental impact reduction. So you can manage these externalities easily by using green building practices. So the most important part in any organization, you know that employees or the occupants are the most important resource the human resource organization. So by ensuring their satisfaction, their comfort level, you're ensuring their productivity. And you know that decreased productivity will lead your production process or your profits to decline. So making your occupants or the employees safe and more productive, you can have retain your profits and more productive workforce. Now that we know about green buildings, there are tools and certification systems related to green building industry. This mostly popular in Sri Lanka are LEED from US Green Building Council and Green as a certification by Sri Lankan Green Building Council. Apart from them, there are EDGE, Platform for Sustainability Measurement, True Zero Waste Certification System, BCA Green Mark, and Well Building Standard. The thing with certification systems is that although they have a cost in the certification process, we can use these certification systems, their guidelines, to steer our green building practices, to act as a guideline. There are some tools like EDGE where we can use these certification tools to measure how our improvement is by our without any certification related, as a self-assessment. So it's important to know about these certification systems related to green buildings so that you can do it yourself even without any knowledge. So the cost part, this comes with a verified source. The US Green Building Council estimated LEED certified buildings from 2015 to 2018 that only these green LEED certified buildings have lead to savings of energy by $1.2 billion. And for water savings, you can see that 149 million is saved. These are some good examples on how to, on the use of these certification platforms. You can see that in each platform, there are energy savings and water savings, material savings recorded. So you can know in a global level where you are using this certification system. Additionally, by using a certification system, you can have a good marketing benefit that your peers, your clients will know that you have taken measures to ensure the sustainability in your buildings, in your occupation, in your occupants. These are some projects done consulted by Coenergi for the LEED certification system. So finally, we have come to a case study from Sri Lanka. The Hydramani clothing Pudukkudiripu facility. We have selected it as it was consulted by Coenergi for the LEED certificate. This was certified in 2017 and taken LEED Platinum rating. So if we look at the energy saving measures taken in this facility, it was estimated that 48% of improvement was recorded in this building using simulation softwares. So the practices they used was roof insulation and with good SHGC valued glass selection. And for lighting systems, they have used efficient lighting like CFL and LED. And we have used biomass steam for renewable energy part. And more than 75% of the space has daylight. So they have reduced the lighting requirement during daytime. So regarding water and material saving, Hairami Pudugudiripu facility has taken non-potable water source as a sewage treatment plant. So they use for flushing toilets and for irrigation this treated wastewater. And they are using efficient flow and flush fixtures, dual flush water closets, and about 40% of water use reduction has been estimated using these efficient practices. 10% of the total materials are recycled and 20% of they will have a lower transportation cost, and about 75% of waste is diverted, or like reusing, recycling, and selling. So it's up to you to decide whether and how to reduce your operational costs using the green building practice or require any consultation. And you have our contact details here. Now I would like to hand over this to Sidel. So Sidel, the floor is yours.
Thank you very much, Mr. Divanta and Ms. Rashadi, for sharing your knowledge and experience with us today. If you wish to consult any queries about this presentation, you could log on to our website and book a session with Coenergi. Before winding up, I would like to thank all our viewers who joined us today. So ladies and gentlemen, stay tuned with us. We are looking forward to bringing you more webinar series like this. Until then, goodbye from all of us at LCG.